Hello everyone! Today our learning goal is to use indirect measurement. Indirect measurement is a method of calculating hard-to-measure distances using similar triangles. So for example, if you had a person and that person had a shadow, and you had a building and that building had a shadow, you could use the height of the person and their shadow and the height of the building and its shadow to make two similar triangles. The height is one leg of the triangle, be it the height of the person or the height of the building. That's one leg of our triangle. The shadow, so the shadow of the person or the shadow of the building, is the other leg of our triangle. The person and his or her shadow meet at a 90-degree angle. The building and its shadow also meets at a 90-degree angle. Now, to complete the triangle, we can draw a line, or imagine an imaginary line, from the tip of the person's head to the tip of their shadow, right there. And then there's another imaginary line going from the corner, the top corner of the building, to the tip of the building shadow. And this makes two right triangles. We know they're similar triangles because they both have a 90-degree angle, so that's one set of congruent angles. And then also, their top angles are congruent. Their top angles are congruent because that angle is made by the angle of the sun. The angle of the sun shining on an object is what determines this angle. Since the building and the person are relatively close to each other, the sun is shining at them at the same angle. So this angle here and this angle here is the same angle because they're both being shined on by the sun at the same angle. So since we have a right angle that's congruent to the other right angle and a top angle that's congruent to the other top angle, these two triangles are similar by the angle-angle similarity postulate. Now you might be thinking, okay, great, we have two similar triangles. How does this help us? Well, it helps us because it's much easier to measure the height of the person, the length of the person's shadow, and even the length of the building's shadow than it is to measure the height of a building. Measuring a height of a building is a complicated thing. You have to get up to the top of the building somehow. You might have to build scaffolding or have someone drop you at the top. Somehow you have to get a measuring tape from the top of the building to the bottom of the building. It's very, very complicated. The other three measurements are fairly easy. It's easy to measure the height of a person. A person's not that tall. The length of a shadow is easy because it's laying on the ground. You can lay down measuring sticks or a measuring tape to measure the length of a shadow. So we can actually use these three easy to measure distances, height of the person and the length of the two shadows, to calculate the height of the building instead of having to actually measure that very hard to find distance. So let's pretend I did that. Let's pretend I measured this person and I found that this person was 5 feet tall. And then I laid a measuring tape down on the ground and I measured this person's shadow, and I found out that this person's shadow is 4.5 feet long. And then I went over to the building and I went ahead and measured the building's shadow, and I found that the shadow of the building was 90 feet long. Using this information, I can now calculate the height of the building. So these are similar triangles, and similar triangles have sides that are proportional to each other. I have to pick one of these triangles to be my new shape and one to be my old shape. So I'm going to have this be new and this be old, and then scale factor is new over old. So in this situation, the shadow here, which is 90 feet long, matches up to the shadow here, which is 4.5 feet long, and I do new over old, so I have 90 over 4.5 is my scale factor. On the other side then, the height of the building, which I don't know, so I'm going to make it h, would match up to the height of the person, which is 5 feet tall. new over old would make this h over 5. So this is my proportion. Shadow over shadow, 90 over 4.5, equals height over height, h over 5. Now I can solve this using cross multiplication. I can multiply 90 times 5 and then divide it by 4.5, and I get that h is 100, which means that the building is 100 feet tall. Let's look at this in another example. Let's pretend now that I had a flagpole. And again, I had a person. Okay. I can calculate the height of the flagpole using similar triangles and indirect measurement. So first, I have to create my triangles. The height of the person and the height of the flagpole form sides of my triangle. So this is the leg of this triangle, this is the leg of this triangle. They meet the ground at a 90-degree angle. The length of the shadow is another leg of a triangle. And then the hypotenuse of the right triangle is from the top of the person's head to the tip of their shadow, and the top of the flagpole to the tip of its shadow. Again, these should be similar triangles. They should be similar because they both have a 90-degree angle, so that's one set of congruent angles. The top angle should also be congruent because the sun should be shining on both of these objects at the same number of degrees. So that's a second set of congruent angles. So by the angle-angle similarity postulate, these are similar triangles. Similar triangles are proportional. So let's say I measured this, and I found that this shadow here was 2 feet long. And let's say that I found that this person here was, I don't know, let's say that person is 6 feet tall. I can go over to the other one and I could also measure this shadow. Let's say I measured this shadow and I found that it was 7 feet long. So this shadow is 7 feet long. And I don't know the height of the flagpole. Instead of measuring the height of the flagpole, which would require me climbing up to the top of the flagpole, I can instead make a proportion and use indirect measurement. So, making my proportion, one of these needs to be new, one has to be old. So I'm going to make this new and this one old. And remember, scale factor is new over old. So I'm going to use this distance, the 2 foot long shadow, new. It matches up with the 7 foot long shadow, old. And then the 6 foot tall person, that's my new. I don't know the height of the flagpole, I'm going to make that H. So now I have shadow over shadow, new over old, is height over height, new over old. Now I can simply cross multiply these to find out how tall my flagpole is. So I go ahead and cross multiply, and I get that my flagpole is 21 feet tall. All right, you guys, I hope that you enjoyed my video. If you have any questions, go ahead and email me. Have a great rest of your day. Bye.